Here we have the integral of absolute value of x squared minus 5x plus 4. And once again, this integral represents the area of the graph of the absolute value of x squared minus 5x plus 4 and the x-axis from -2 to 4. And this is the graph right here. This is the function of absolute value of x squared minus 5x plus 4. And we want the area from -2 to 4. And so for this particular type of function, we have to break this integral right here into two separate integrals. So the first integral, it looks like it would be from -2 to 1. And then the second integral would be from 1 to 4. And so first we need to get the antiderivative before we can find the area of these two regions. So this would be region 1, and this would be region 2. And so to get the antiderivative, first we need to rewrite this absolute value right here using the definition of absolute value. So this absolute value here, it means this. It's equal to whatever's inside the absolute value if this is greater than or equal to 0. And then the opposite, if this expression is less than 0. So that's the definition of absolute value. And then what we need to do is solve this quadratic inequality right here, so we know exactly where x is, and then same thing here. And so we want to solve this quadratic inequality right here, and we don't have to do both. We just do the first one, and then that will also give us the second one. And so to solve this quadratic inequality, first thing we'll do is go ahead and factor if it's factorable. And so in this case, it's x minus 4 and x minus 1. And then write the corresponding equality. And then now we're going to graph this, the x minus 4 and x minus 1, and then will help us see where the graph is above and where it's below the x-axis. And this is the graph of the function x minus 4 times x minus 1. And so if we go to the graphing calculator and then input the function x minus 4 and x times x minus 1, then we get this graph. And if we look at the graph from the left side to 1, the graph is above the x-axis. From 4 to the right side, the graph is above the x-axis. And then from 1 to 4, the graph is below the x-axis. So what that tells us is this. The x minus 4 right here is greater than or equal to 0. On the interval from negative infinity to 1, and then also from 1 to infinity. And then it also says that this the x minus 4 and x minus times x minus 1, this is less than 0 on the interval from 1 to 4. And then if a graphing calculator is not available, then what we do is we solve this equation right here. And so we get x minus 4 equal to 0. Or x minus 1 equal to 0. And then here we get x equal to 4. And then here we get x equal to 1. And then we would set up 3 intervals. The interval from negative infinity to 1, 1 to 4, and then 4 to infinity. So we set up 3 intervals. And then 1 to 4, and then 4 to infinity. And then what we do next is we pick one value from each interval. We pick test values. And then test each one. So for example, like the first interval, a number that's inside this interval, it would be x equal to 2. And then we would take the 2 and then plug it in, and then put the 2 into this, plug the 2 into this inequality and see if it's true or false. And so if we plugged it in, we will see that it's true. And so we plugged in the 2 here, and then the 2 here, and this would be true. Because this is 4. Let's try that again. 2 is not in this interval, so let's pick 0. And so 2 is in this interval. 0, and then 0. And so here we get 0 minus 0 plus 4, and 4 is greater than 0. And so we pick the one number from this interval, and this number right here is true, then any number, then all numbers, all values in this interval will be true. And then now we can pick 2 for the middle interval. And so this will be 2, this will be 2, and this is less than 0. Because this is 4 minus 10, which is negative 6. 6 plus negative 6 plus 4 is negative 2. And so we pick any number between 1 and 4, then the inequality will be less than 0. And so that's how we would, if we don't have a graphing calculator available, then that's what we need to do. Is the process is like this. Form the intervals and then pick a test value from each interval and then test it and see which interval is true and which interval is false. And so now back to our integral problem here. And so this inequality greater than 0 on these intervals. So what that means is this. This is the same as this. So if x is any number between this inequality right here, if x is any number, this inequality is equivalent to this. If x is any number in this interval or in this interval, And then for down here, if x is between 1 and 4. And then now we can set up the integrals. So it means that this integral will be from -2 to 1, and then we have to decide where is -2 to 1. Is it in this interval, or is it in these intervals? And so -2 to 1 is in this interval, and therefore we will use this for f of x. And so this will be the integral from -2 to 1, and then the function will be this. And then the second integral, it will be from 1 to 4. And then we have to decide where is 1 to 4. Is 1 to 4, is it in these intervals, or is it in this interval? So it's in this interval. And then right here, we can rewrite this as this is negative x squared plus 5x minus 4. So we multiply everything by -1, we get negative x squared plus 5x minus 4. So this will be this, and then dx. And then now we have two separate integrals, and we need to evaluate each one separately. So let's do the first one. So with this one, the antiderivative of x squared, add 1 to the exponent, so we get x to the third, and then dividing by 3, and then minus 5 times, this is x to the first, and so antiderivative be x to the second, dividing by 2, and then antiderivative for the constant 4 is 4x. And again, fundamental theorem of calculus says that this is f of 1 minus f of -2. And so we need to evaluate the antiderivative for x equal to 1. And then simplifying, we get 11 over 6. And then similarly, we need to evaluate the antiderivative -2. And that comes out to be -62 thirds. And so this right here, the first integral, would be 11/6 minus -62 thirds. And this is going to be 45 halves, or 22.5. So the area of the first region is 22.5. And then now we need to evaluate the second integral. And so for this integral, again, by the fundamental theorem of calculus, this is f antiderivative at 4 minus antiderivative at 1. So the antiderivative This is negative. This is x squared, so the antiderivative, add 1 to the exponent, we get 3, and then dividing by 3. And then this is 5 times, this is x to the first, so antiderivative is x to the second, dividing by 2. This is a constant, so it'll be just constant times x. And then we need to evaluate the antiderivative at 4. And then we need to evaluate it at 1. And then evaluate, we get 8/3, and then for f of 1, we get negative 11/6. And so this right here becomes 8/3 minus negative 11/6. And this will come out to be 9 halves, or 4.5. So the first integral is 22.5, the second integral is 4.5. And so what that means is that the area for the shaded region, this shaded region is 22.5, and this shaded region is 4.5, and then altogether is 27. And so altogether the shaded region, the entire shaded region is 27.